Now let's look at which one we are going to continue with in order to determine the order of monoreactants, order of reaction. Okay, so now we are going to focus on linear graph by using integrated rate equation. Another one is we can use Rate's law. So determine the order of reaction involving single reactants using linear graph method based on the integrated rate equation and also Rate's law. Okay, first of all, let's look at the question. Okay, the dissociation of dinitrogen pentoxide is it tells you already easily, is a first order reaction. Okay, then it gives you time and concentration. And then when you plot graph, be careful, it's 10 times 10 to the power of -4. Okay, then next one, the requirement is plot a linear graph to prove that the reaction is a first order reaction. So you must use linear graph. Don't use half-life. If you use concentration versus time, it is incorrect. Since it already mentioned it is a first order reaction, so what you need to do is write the integrated rate equation for first order reaction. Of course, here we have dinitrogen pentoxide, so your reactant is N2O5, not A. Okay, then how do you determine whether it is Y or it is X? Okay, now let us do one by one. Okay, so first of all, there's something that you need to take note that is initial concentration. Okay, initial concentration only happen once. That is when time equals to 0, when the reaction hasn't started yet. So you cannot use time. Okay, it doesn't make sense. So here you've already know it is concentration. So this is the intercept. Okay, now if you know that ln A concentration, okay, so this is C. So another one will be, the concentration will be Y. Okay, but you need to use ln. Okay, if you need to use ln, then you need to add another column, add another data row on your own. Okay, after that, time is given, okay, it is variable, it can change, and then the gradient will be the rate constant. That's why we have a negative slope. Okay, so let's see, after you plot the graph, okay, remember time given minute. Okay, so after you have plot the time, the graph, okay, so is it a first order reaction? Okay, you have intercept, yes. Then it is a negative slope, okay, and then it is a straight line. Okay, so this is a first order reaction. Okay, another method is you can use rate versus concentration. That is using the Rate's law. Okay, the Rate's law is quite easy because you can see that the shape of all the graphs are different. Okay, so remember the rate is concentration over time. So if you plot concentration versus time, then it is incorrect. Okay, now let's look at another example. Okay, here it tells you that determine the order reaction. It didn't mention whether it is 0 first or second. Okay, the requirement is just stating that using graphical method. Okay, using graphical method, you can use linear graph or half-life. Okay, so of course the easiest way would be using the half-life, because half-life is just concentration versus time, and then we have time given, concentration. We do not need to calculate for another information. Okay, the value for another information. Okay, so try half-life method. Okay, so after you plot, you compare the first half-life and the second half-life, and you find that the second half-life is 2 times the first half-life. So you know that this is a second order reaction. Okay, easily you know that this is a second order reaction just based on half-life method. Okay, so remember this one you need to write in your for your answer as been taught earlier. Okay, now let's try linear graph method. If linear graph method, one graph only represents one order. Okay, so let's say we try first order. Okay, if you use first order, write the integrated rate equation for first order. Okay, just like now. Okay, so but when you plot, you still have the intercept, but this time you didn't get a straight line. Okay, if it's not a straight line, then this is not a first order reaction. Okay, although we know that this is not a first order reaction, but we cannot say, oh, since it's not a first order reaction, then it is second order reaction. Cannot. Okay, it only gives us the information that it is not a first order reaction. So you need to try again. Okay, this time you try second order. Okay, again, same thing. You have intercept. Okay, let's look at this. The gradient is positive. Yes, gradient is positive. And then you've got a straight line. Okay, so this time straight line, positive slope. Okay, so this is a second order reaction. Okay, let's say if you didn't try second order, you try zero order. So means you spend another maybe 5 minutes to prove that it is not a zero order reaction. So of course, the easiest way would be to use half-life, because using half-life, you know whether you know whether it's zero first or second. Okay, for zero is easy. Zero is just a linear graph with negative slope. If it's first order, okay, if it's first order, it will be the first half-life and the second half-life would be the same. If second order, the second half-life would be 2 times the first half-life. Okay. Now, so what is the difference between this sample exercise? If the question mentioned plot a linear graph, then you must use integrated rate equation. Okay, another one is determine the order of reaction using just graphical method. The word is mentioned. Okay, so you can choose either one, integrated or half-life. Okay, so the graph which shows straight line with the correct slope is the order of reaction. Okay, the points to remember. Okay, concentration versus time. Half-life can determine either zero first or second order in just one graph. Okay, but remember to show second half-life is how many times? First half-life. Okay, if you use linear graph, okay, linear graph, it all can only determine certain order of reaction in one graph using just one integrated rate equation. Okay, in order to help you to plot graph easily, use y equals to mx plus c together with integrated rate law. Okay, so that's all for this part.